In this video, we're going to discuss how to find the velocity of a wave in a fixed medium, as well as give an example of a problem in order to find wave velocity. Now, if you think about velocity, we know velocity, the key unit is meters per second. And that's going to hold true when we're talking about the velocity of a wave as well. So that means that in order to find the velocity, we're going to need to know the distance. We're also going to need to know the time. And luckily, we already know both of those, because we know that the wavelength is the length of one wave, and that's already in meters. So we know that. Now, in terms of the time, we know the period is the time for one wave in seconds. So if we really wanted to find the wave velocity, all we have to do is take the wavelength divided by the period. Now, this isn't the most common way to actually write this out. The more common way to do this is, instead of using the period, we're actually going to use the frequency. And that's because we know that the frequency is 1 over the period. So if I just take the frequency as 1 over the period, if I substitute that in, what I get is velocity equals the wavelength times the frequency. Or I can write it the other way. Velocity equals frequency times the wavelength. Either way, this is how you find the velocity of a wave. Now, the important thing about the velocity of a wave is that it does not change in a fixed medium. So if you're talking about air, the velocity of a certain wave in air is going to remain the same no matter where it is in the air. Same thing with water, same thing with just other media that exist. So that wave velocity is going to remain constant. So let me just give you an example of how to calculate this. Let's say we have here that the wavelength of a particular wave is 0.59 meters. And let's just say that the frequency of this is 120 hertz. If we wanted to figure out the velocity of this wave, all we have to do is just plug in our value, so 120 hertz times that wavelength, 0.59 meters. And that will give us our wave velocity. So 120 times 0.59 is going to give us 70.8 meters per second. Now, what I was trying to mention to you is that the only thing that really can change here, if you're talking about a fixed medium, are the wavelength and the frequency. The velocity will remain 70.8 meters per second. So what that means is that if you were to change this wave, this velocity would remain the same. These two values would have to change. So there is a proportional relationship. If you look at these, that means there's a proportional relationship between the velocity and the wavelength. There's a proportional relationship, direct relationship between the velocity and the frequency, but the wavelength and the frequency have an inverse relationship. So as the wavelength increases, the frequency is going to decrease. And that's an important thing to make sure that you understand. So when we talk about some of our different waves, like when we go into standing waves, when you start looking at when the wavelength changes, please keep in mind that the frequency change is going to be the inverse of what happens to that wavelength.